Guys, in this video we are going to evaluate this kind of series. So we are asked to find the sum of this series. What is the series? N goes from 1 to infinity, n plus 2 divided by n times n plus 1 times 2 to the power n. So here we have a rational function, so we can split this one into partial fraction. So let's do that part first, right? So here you have n plus 2 divided by n plus 1, right? So first thing is to split this one into partial fractions. So first term n, the factor is n plus 1, so partial fraction. So just yeah, so you can, so here both, so the degree of the denominator function is 2 and the numerator is 1, then so the degree of this polynomial is less than the degree of the denominator function polynomial, right? Then so we add a coefficient a and b, right? So here I cross multiply by n times n plus 1, then I get this equation, a times n plus 1 plus bn. So comparing coefficients of n on both sides, left hand side is 1 and right hand side is a plus b, and by comparing coefficients of constant terms, so left hand side is 2, so right hand side is a. Here a is equal to 2, and then from first equation we can find b value of b, which is -1. So these are the partial fractions. So here denominator is n plus 1. So a is 2, here you have n, and b is 1 minus 1, n plus 1. Let's look at the numerator. Numerator is n plus 2 here, n plus 2. Alright, we found the partial fractions. Then so let's go to our problem here. So here we have 2 to the power n. So I multiply whole equation by 1 over 2 to the power n. So I write that in red. So here 2 to the power n, here 2 to the power n times, this one times 2 to the power n. When you simplify this bit of right hand side, we get 1 over n times 2 to the power n minus 1 minus 1 over n plus 1 to the times 2 to the n. So notice these two terms here. So this is your first term, right? So here look at this. If you replace n with n plus 1 in this term, what do you get? You get this term here, right? So this becomes n plus 1, and 2 to the power n minus 1 becomes 2 to the power n. So if this one is nth term, then this is your n plus 1 term, right? So notice that. So let's denote this one is your un, right? Let's, alright, okay. When n is equal to 1, u sub 1 is equal to 1 over 1 times 1 minus 1 over 2 to the 2 square, and when this is n equals 1, right? N equals to, you get u sub 2 1 over 2 to the 2 squared. Same term here appearing here. So minus 1 over 3 times 2 squared. So when you sum these two terms, you can cross this off. These two, you can cross these off, right? Okay, let's carry on. When n is equal to 3, u sub 3 is equal to 1 over 3 times 2 squared. So this term is with this quantity, but the sign is negative. Then you can cross this off when you sum that these two terms up, right? And the next one is 4 times 2 to the 2 cube. You saw the pattern, and the final term u sub n, not final, this is the general term, 1 over n times 2 to the n minus 1 minus 1 over n plus 1 times 2 to the n. When you sum these all up, so you can cross from here, you can cross these off. And finally, what are the remaining terms? So here, from here you get 1 here, right? Sum r goes from 1 to n. So 1 minus n, this is the other remaining term. 1 minus 1 over n plus 1, 2 to the n, right? So if you want to find this infinite series, so our question was this: find this infinite series. Right. All you need to do is, what you want to do? You want to take the limit. Just take the limit. Let's take and take the limit. Let's take in n going to infinity. Your left hand side r from 1 to infinity, u r is equal to, what happened to this term? As n tends to infinity, this term goes to 0, then you that you then this infinite series is equal to 1, just 1, right? So I hope you understood uh, this problem very clearly. Let's do a couple of problems in my next video, right? I'll see you there.